This section is called Other Equations in the textbook, and we use factoring, we use quadratic formula, and we apply it to word problems. And to be honest, it's quite a variety of ways to solve these equations. So it's hard to teach any one method to approach these. And on this number 9 and 10, I say to solve by factoring, so let's give that a shot. On number 9 right there, we see it has an exponent of 4 and an exponent of 2. Since that largest exponent is larger than 2, we can't use quadratic formula. If the largest was a 2, then we could just use quadratic formula and not factor. But factoring is the best way I can think to solve this. So remember, in order to factor, we need to get everything to one side. So I would move that 27 over, and then we have this, and it's set equal to 0. And then don't forget what you always look for before you do any other types of factoring. You look for a GCF. So it looks like the largest number that goes into both of those is a 3. And the largest x that goes into both is x squared. Remember, you can only take out as many as the smallest exponent. All right, then in parentheses we write the leftover. Looks like we have x squared left, and we have a minus 9. If you're still confused on that step, think about it as if I was to undo this and distribute this out, would I have the original problem? And yeah, 3x squared times x squared is 3x to the 4th. 3x squared times negative 9 is negative 27x squared. Okay. At that point, you're about done. You just set each factor equal to 0. So you set that equal to 0. Well, actually, sorry, got ahead of myself. We have to factor that parenthesis, because that is a difference of 2 squares. I mean, we could have set that equal to 0, and we would have solved it just fine, but this way makes it a touch easier. All right, now set each thing equal to 0, and you are about done. So that means x is 0, 3, and negative 3. All right, let's try one with 4 terms. We've worked one before, and I gave you some hints. If we ever have 4 terms, attempt factoring by grouping. But once again, we need everything to one side. So x cubed plus x squared minus 4x. People are messing up on this step. They're just writing the 2 terms on the other side, but the signs have to flip. All right, next step, you group the first 2. Now, this strategy doesn't always work. It sometimes works. I'd say it usually works. And then you group the next 2. But you need to be really careful how you write this, because we have negatives, and we're not multiplying any of these terms. So I have to write a sign between these, so I put a plus. All right, then you take a GCF out of each group. Looks like an x squared, and x plus 1 is left. Looks like both of those have a negative 4, and x plus 1 is left. If you're confused, pause it, look at it. The signs have to flip if I take a negative out. And my goal in this is to get these 2 to match. And notice they do. I have an x plus 1 and an x plus 1. So that becomes a GCF. Maybe I can color code this thing. So I'm going to take the red out of each term, and that's a GCF of x plus 1. And then you write the leftover in another parenthesis. Hopefully that makes sense. It's a very confusing method of factoring. All right, I can break that x squared minus 4 into two things, just like I did on that first problem. Whoops, not a 3, sorry. Flashbacks to the other problem. And we're about done. Set each factor equal to 0. And we have x equals -1, +2, and -2. Hopefully that made sense. All right, let's try a word problem. Now, like I've said in the past, it's hard to teach one way to solve word problems. So your best way to approach these is practice. You just want to practice word problems over and over again, and I don't know, you just get more used to reading through these big paragraphs and figuring out what they want. You ask specific questions about it. So Galapagos Islands have all kinds of wildlife. They're west of Ecuador, but they don't even want to know anything about wildlife. They want to know something about number of plant species. And they give us a formula that predicts number of species if we know the square area of the island. So what if I know there's 57 species? Could I figure out how big approximately the island is? 57 resembles what letter? Take a moment, look at this sentence right here, and it tells you. S is number of plant species, and X is the area. So we're trying to find X. Plug 57 in, and we'll go to the calculator here in a second. I would divide both sides by 28.5. And this one is a nice SAT problem because we get a nice round number of 2. So then to get rid of that cube root, you cube both sides. Which gives us 8. So I would say 8 square miles, or you could be fancy and write miles squared. All right, let's work one more problem. And this is one with a square root. We've worked with some with square roots, but never with an expression under the radical. So anytime you see this, anytime you have a square root, especially with an x under it, our ultimate goal is to square both sides. But we need to isolate the radical. I need to get everything away from it. So write that down, and that'll help you out in later quizzes and tests. Isolate the radical, get everything to one side, except the radical, and then square both sides. All right, I'm going to move the x over. Radical is now isolated. Let's square both sides. And the nice thing on the left is the radical and the 2 cancel out, and I have 26 minus 11x. On the right side, I have 2 of those, so I need to FOIL that out. Some of y'all have the pattern memorized, but I'll FOIL it out this time. So I go 4 times 4, 4 times negative x times 4, negative x times negative x. I see a x squared and an x term, which means I'm going to have to move everything to one side and factor or do quadratic formula. So I'm going to subtract the 26. I'm going to add the 11x. And I have something that looks like this. I'm just going to write it all down. Pause it if you need to. See where all those numbers came from. I have x squared. I have plus 3x and a minus 10. That is easily factorable. If I don't see how to factor it, I usually go to quadratic formula, but this was an easy factoring one. I hope you think that. That means our answer is -5 and 2. All right. Any questions, please message me. Come into tutorials, let me know. Hopefully that made sense. Oh, actually, by the way, with square roots, it's good to plug things in. Let's double check those answers. So we have a -5 plus 26 plus 55, because 5 times 11 hopefully equals 4. And let's see, what is that? 75, so 81, so that's 9. That checks out. Plug in a 2, and I get 26 minus 22. And that gives me 4. Square root of 4 is 2. That checks out as well. We were safe. But there's always a chance it might not check out. All right. See you in the next video, and see you in class.